We need to obtain the derivative of y with respect to x whenever x and y are given in its parametric form. That means x and y are both dependent on the parameter theta here. So let's begin. We'll start with our first function x, which is given by e times cosine of theta plus theta times sine theta. Let's begin by taking the derivative on both sides with respect to theta. So this gives us dx over d theta equals to a times, so we'll take derivative of cosine of theta plus derivative with respect to theta of theta times sine theta, right? Which will be a multiplied to the derivative of the cosine function gives us the negative sine theta, plus here we'll have to apply the product rule. So we'll take theta is the first function, so we have derivative of the first function multiplied to the second function, which is sine theta, plus the first function multiplied to derivative with respect to theta of the second function, that is sine theta. So this will be equals to a multiplied to negative sine theta plus derivative of theta with respect to theta, that's 1, so we have 1 times sine theta. So this gives us positive sine theta plus theta times derivative of the sine function will be cosine theta, which means we have negative sine theta and positive sine theta cancelling out, and that leaves us with a times theta cosine theta. So this is going to be the value of derivative of x with respect to theta. So we're going to label this as equation number 1. Next, we will start with the parametric form of y, which is a times sine theta minus theta cos theta. Now we'll take the derivative on both sides with respect to theta. So we have derivative of y with respect to theta, that will be equals to a multiplied to derivative with respect to theta of sine theta minus derivative with respect to theta of theta times cosine theta. That will be a multiplied to derivative of the sine function gives us the cosine function. So we have cosine of theta, and we'll apply the product rule. So we have negative theta times derivative with respect to theta of cosine theta minus cosine theta multiplied to derivative of theta with respect to theta. This will be a multiplied to, so we have cosine of theta minus theta times derivative of the cosine function gives us the sine function, but it will be negative, so that means we have positive sine theta minus cosine theta times derivative of theta with respect to theta, that's 1. So we have cosine theta and negative cosine theta cancelling out. This gives us a times theta sine theta. So this is the value of derivative of y with respect to theta. We're going to label this as equation number 2. So previously obtained derivative of x with respect to theta as a theta cosine theta. Now we have derivative of y with respect to theta is a theta sine theta. Now using 1 and 2, what we'll do, we can obtain derivative of y with respect to x. So derivative of y with respect to x is simply derivative of y with respect to theta whole divided by derivative of x with respect to theta. The derivative of y with respect to theta we have obtained as a theta sine theta, and derivative of x with respect to theta as obtained in equation 1 was a theta cosine theta. So here a theta gets factored out from both the numerator and the denominator, and the ratio sine over cosine, that is the tangent function. So we have tangent of theta, and hence we can say that derivative of y with respect to x will be now tangent of theta, and this derivative is also is given in its parametric form. That means it's dependent on the parameter theta.